Very good morning, everyone. Welcome back to my channel. So today I want to explain you about a friction. So the friction is actually related to the first year topic. Friction is nothing but it is a one type of force. This is the first one. Actually, I am telling basic related to the friction. So friction is nothing but it is a one type of force. This is the first point. And coming to the point is friction is nothing but a electromagnetic in origin. This is the second point. And friction is nothing but we can say it is due to molecular force. I'll explain you one by one. And friction is nothing but due to adhesive and cohesive force. And friction is a non-conservative force. And friction is always act tangential to the surfaces in contact. So this is related to the friction. See, friction is due, it is actually one type of force. Of course, it is a one type of force. So force we know, like here friction also one type of force, and which always it act opposite to the motion of a body, which always act tangential surfaces in contact. Tangential surfaces in contact is nothing but see, there is a two surfaces are in contact. Between the two surfaces, the force is act parallel to the surfaces in contact, or parallel to the surfaces of the bodies in contact, which we can call as a tangential force. And there is another one. Friction is actually due to electromagnetic in origin. That means here, when the two bodies are one above the other, therefore, when the two bodies are pressed together, when it is pressed together, there it is to be electric and magnetic forces are develops. That's what we can say. There is electric field and as well as magnetic because of pressing of the two bodies, or when one body is placed on the above the other surface of the body, then here there is a electric and magnetic fields is develops. That means here the molecules between the two surfaces are activated. So we can call it is electromagnetic in origin. And here there is a third point is friction is due to molecular force. Of course, molecular force is nothing but suppose I want to say there is a pen. If I take a like this, if two surfaces are in contact, say there is a this body molecule and this pen body molecules are in contact, so that there is a electric and magnetic forces are develops. That's what we can say electromagnetic in origin, as well as is a frictional force is it is a molecular force. That means here the molecules are in contact. It is a one. And here there is a frictional force is a due to adhesive and cohesive force. Sir, what is mean by adhesive force and what is mean by cohesive force? So the adhesive force is nothing but the force of attraction between two different molecules. So that we can say adhesive force. Cohesive force is nothing but the force of attraction between the same molecules. So the force of attraction between the same molecules are nothing but a cohesive force, and the force of attraction between the two different molecules are nothing but a adhesive force. See, frictional force is a adhesive and cohesive force, because if you take a like two different bodies, it is a one pen is a one body and here a hand, these molecules are different. When they are in contact, there is a force between the two molecules, different molecules. Yes, we can say frictional force is a adhesive. Cohesive is nothing but the same molecules. Yes, you take any one like a water molecule, there is a force of attraction between the water molecules, same molecules. That's what we can call it is frictional force is a cohesive and adhesive forces. That is what we can say about a fourth point. And coming to the frictional force is a non-conservative. Non-conservative in the sense is, you remember there are conservative and non-conservative. See, non-conservative is nothing but in any given a closed path. See, the frictional force, work done by the frictional force in a given a closed path is not equal to zero. This is the point which is very, very important. See, non-conservative in the sense is the work done by the frictional force in a given any closed path is not equal to zero. If it is not equal to zero, it's nothing but we can call non-conservative. If it is equal to zero, we can call as conservative. Of course, frictional force is a non-conservative force, because in a given a closed path, the work done by the given any closed path of a rough inclined planes, so that that is we can say non-conservative force. And here coming to the direction of frictional force is always tangential. Now I want to explain you one example. Let us you take a one surface which is rough like this. Here and there is another block of mass m is placed on the rough surface. So suppose if the body is moving like in the direction, any direction you take, suppose I want to say this is moving along the direction, it is parallel to the surface, so that when it is moving there will be a frictional force is act opposite to the motion of a body, that is between the two surfaces are in contact, between the two surfaces are in contact. See, the two bodies are in contact, no, then there will be a frictional force is acting between the two surfaces are in contact, so that when it is moving there will be a frictional force is always act opposite to the motion of a body. That means here there is a tangential force is nothing but a what? The force is acting between the two surfaces in parallel. The parallel in the sense is we can call tangential to the surfaces in contact. So this is about a last in case of a frictional force. So what is meant by frictional force? Of course, frictional forces which always act opposite to the motion of a body and which is tangential to the surfaces are in contact. If two bodies are in contact, therefore there will be a frictional forces act opposite to the motion of a body which are in contact. That means when the two bodies are in contact, that is there will be a force is acting opposite to the motion which always act opposite. It is opposes the motion. That's what we can call frictional force is a tangential which always act, it is opposite to the motion of a body, which we can call as a friction. This is related to the friction. And here I want to tell you one more example related to the friction which always act opposite. Sometimes it also support the motion. It is also support the motion. See, suppose here I will tell you some advantages related to the friction. See, friction we can hold the pens because there is a frictional force between the two surfaces. We can hold the like bodies without slipping because there is a friction is more. Like here when bodies, suppose when man is walking on the surface of the body, surface on the road, so that friction is support the motion. That means here when we are walking on the road, therefore our leg, that means here our leg is pushes the earth or road in the backward direction, like I'll show you. So suppose here it is our leg is pressing the road like in the opposite, so that here the leg presses, therefore leg is moves in the backward direction and the frictional forces act along the direction of a motion of a man or walking in the direction, so that this leg is pressing back, no? Therefore there is a frictional force is act along the direction of the man moving. That is nothing but a what? Frictional force is sometimes it is support, sometimes it is oppose. That's what we can call there is a frictional force is support us because we are walking on the road without slipping. Without slipping in the senses we are walking, no, there will be a frictional force is acting between the road and the feet. So in this case what happens? That friction is act along the direction of a moving man and there is a leg is moving in the backward direction. See, this is the leg moving back and the frictional force is acting in the opposite in the same direction. So it is supports. And here I will tell you one more example also related to, like, suppose if a bicycle you take, see, for this bicycles it is also we can say like this. See, you take a wheels for the cycle, given a cycle, look at, say this is the two wheels, alright. See, when we are pedaling, that means your cycle is moving. When we are pedaling, see, you remember there is a condition, say both the frictional forces are act in the opposite direction. That means your back wheel act, the friction is in the forward direction, front wheel is act in the direction opposite to the back wheel. Then the bicycle is moving. So this is the case when the cycle or bicycle is while pedaling. So both the wheels frictional force is act in opposite direction. That means back wheel friction is act in the forward direction and the front wheel frictional force is act in the backward direction. Because of this two are in opposite, then the bicycle is moving. See, while it is pedaling, suppose if, that is we can say if stopped, that is mean your pedaling is stopped. Therefore in this case both the frictional forces are act in the opposite direction for both the wheels. That means your when pedaling is stopped, therefore both the wheels frictional force is act in the backward direction. Therefore the bicycle stops. See, this is regarding friction. That's what here you remember. friction is a one type of force which always act opposite to the motion of a body, which opposes, and sometimes it is supports also. So it is related to the friction, some introduction part related to the friction, right? And we'll continue in the next video related to the friction. I'll tell you related to the JE and NEET related topics, as well as I'll discuss some problems related to the friction and other concepts also. Thank you very much. We'll see you in the next video.